So when you go into Moodle, you'll see that there's this L1 icon. That is the lab. That's where the lab is entirely done. However, there are two documents, a PDF and a Word file, which you'll need to use for the in-lab part. And whichever you choose, the Word or the PDF, you'll submit that in here. So let me open L1 and go in, and you'll see that there's 5 items in here. And so completing the lab means completing these 5 items. And it's item 2 where you'll submit the document that I showed you. And the document will contain your data and the work that you do in lab for lab 1. The first question is questions about the material that's in the first 2 pages of the lab document. So you need to refer to the first 2 pages of the lab document where all these topics are discussed to answer question 1. Then there were 2 activities, calculating the density of a cylinder and measuring the height of a flagpole. That's what you're going to do in lab, and that document is going to be submitted here in Moodle. Then after that, there were 3 more questions. One is a computer simulation, which uses a vernier caliper measuring device, and so that will help you prepare for lab if you do that. Another is a computer simulation involving moving objects. This is not so important that you do it before lab, but you do need to do it as one of your post-lab assignments. And the last thing is this assignment from the physics classroom, doing these concept builder exercises. And this is a practice in significant figures and in measurement. And so of all these other 4 items, probably number 5 is the most important to do prior to the lab. So let's see if I can open this, if this will open for me here. Okay, so there's 4 animations, and you're going to do each of these and answer the questions asked in that Moodle question. But people often ask how to use the vernier caliper. And if you grab this, if you grab this red dot, well, it's not going to work in this format, but you can slide this back and forth. And if you close it, what you'll see that the 0 here will line up with the 0 here. And so as you slide it, this 0 line moves. And right now, you can see it moved 1 centimeter, and then 1, 2, 3, 4, 5, 6. So it's between 1.6 and 1.7. And it's a little bit less than halfway, so you might guess that it's 4. But we can do this more precisely using the scale here and the scale on top. And if you look, none of the lower lines line up with the upper lines except for this one. So you see the 1, 2, 3, 4 line lines up exactly with the 2 line. And so that means that third digit is a 4, because those 2 lines line up and none of the others do. So the reading in this position would be 1.64. That's how you use the caliper, and use it in these 4 animations and answer the questions. So scrolling down to the next question, number 4. Let's see if we can open that one. And this one is 2 different animations. Let me see if I can play them for you. So when I do the start button, there are 3 objects, so-called star, a man, and an an electron, so objects of vastly different size. And they're moving along this grid. And you see they're kind of moving at a constant speed. And then when the animation comes to an end, it stops. But the animation starts and stops. It doesn't mean the objects start and stop. The objects, if you take measurements, you'll see they're moving at a constant velocity. And if I reset it, so the objects are still, and when I start the thing, they're moving. But that doesn't mean they started moving when I pressed the button. No, they were already moving. And so you have, let me pause it. Notice you have time measurements up here, and you have position measurements along this scale. So let me see if I can get those to display. Anyway, when you do this, you can put your cursor in the position of any of these objects and measure their position. And so you can get position time measurements, and that's how you calculate the velocity. Oh, you see, there's the position showing down here. Now, you can't see my cursor, but wherever the cursor was placed, it has an x coordinate of that and a y coordinate of that. And by placing your cursor in different places, you can get any position measurement you want. And so this is what we're going to do these. Even though we have the in-lab part, we're still going to use the simulation experiments. And so you will be taking measurements on the screen in these simulations. In this case, you'll answer the questions asked about this simulation. And scrolling down to the 5th question, there are, I think, adequate instructions for doing this. There are 2 tasks. Each have 3 parts, so there's 6 parts in the physics classroom. And there are instructions on how you register and how you do those exercises. So I think you'll be able to follow that. Let's see if I can open this. And so when you scroll down, you go into a task tracker at the bottom in order to register. Let me go back. Whoops. There's the task tracker. And here are the concept builders. And here's your Minds on Physics. When you'd be using those next week. But in the lab, we have two tasks out of this concept builder. And if I open the concept builders, you'll see that you're looking for, near the top, the measurement in units. So if I tap on measurement in units, it opens up. And the 2 tasks that we're going to do are metric estimations and significant digits. And as you'll practice in the lab, doing reasonable estimations just from limited knowledge is good practice. And understanding the details of significant figures is important. So these 3 activities in each of these 2 tasks will be good practice for you. Okay, I hope that helps.